My section starts with Newton's second law, which is force equals mass times acceleration. It talked in the book. It talked about how the MCAT will try to make problems sound very difficult, but it can easily be solved with using this equation. Some misconceptions that students have is that a constant force will not make an object accelerate faster and faster, meaning that a constant force can cause an object to move, which is displacement. And displacement, when a constant force is applied, I wrote down some of the graphs. Displacement is not linear, and velocity is, and acceleration is constant. Then we go to Newton's third law. This law talks about that whenever one object exerts a force on the second object, the second object always exerts an equal and opposite force on the first object. Basically, what this means is that for every action, there is an equal and opposite reaction. I found this diagram, which I thought was very helpful, and it just talks, it's two blocks, a 50 Newton force block and a 200 over a scale, and the scale's on top of a spring. And overall, it has a zero net force, because all of the forces are acting against, well, not necessarily against each other, but they are canceling each other out. Basically, the scale supports both blocks, so it has a 250 force going downward. The scale is exerting a 200 Newton force going upwards to the blocks, and it's the same for the 50 Newton force blocks. Then it goes on to talking about linear motion. It says that displacement is the shortest distance between point A and B. It's a vector indicating the change in position, so it doesn't depend on the path. And then it asks you to compare distance and displacement, and basically distance is a measurement of travel, which is path dependent, and displacement is not. And it's also a vector, and it's the change in position. Then it goes on talking about velocity. Velocity is a change in displacement. It also asks you to distinguish between speed and velocity, and speed is a change of distance. And then it says that on the MCAT, you can treat speed the same as velocity only if the question makes it clear that the distance traveled is a straight line. Then it talks about constant velocity, and it says that it's literally the most frequent tested MCAT principles, which is that when you see constant velocity or constant speed, think that 1, no acceleration, 2, no net force, 3, all forces sum to 0, 4, no change in direction, and 5, the object is in equilibrium. Acceleration is any change in velocity. An important number that we have to know is that 10 meters per second squared is approximate acceleration of gravity. Then it talked about the linear motion graphs, and those some key steps for interpreting the graphs is that 1, what does the slope mean, which is for example, the slope in a displacement versus time graph, slope is the velocity, and in a velocity versus time graph, the slope is acceleration. For 2, is the slope positive or negative? What does the sign of the slope tell you? For example, in a positive slope on a displacement versus time graph, velocity is positive, meaning that the motion is going to the right. In a velocity versus time graph, the sign tells us about acceleration, the direction of the vector, where the vector points is the direction of the force. It doesn't tell us about where it is going, if it's going right or left. If the slope is constant, then we will observe a straight line, or if it's not a constant, then a curved line. It is also important to note what value is on the y-axis, and is a y value positive or negative, and what does this observation tell you? For example, in a displacement versus time graph, when the line is above the x-axis, it is positive and the object is to the right of the origin. Then when the line is below the x-axis, the object must be going to the left. In a velocity versus time graph, the location of the line above or below the x-axis tells you the sign of the velocity, regardless of whether the object is going to the right. And lastly, do you expect the value on the y-axis to be large or small at the beginning? For example, a ball being thrown in the air. If the initial velocity is 0, the ball won't travel upward. The velocity should have a large magnitude at the beginning and then decrease with time. It talked about how many students always choose a graph that starts at the beginning, like at the 0 of the x-axis, and it's not right. It should always be higher, because the initial velocity is not always 0, especially if a ball is being thrown in the air. How to solve a linear motion problem in your head. It talked about this and how to do it fast. First, you have to conceptually define acceleration. So basically, acceleration is a change in velocity at each second or rate of change of velocity. It can be positive or negative velocity. And then you have to know how to calculate the average velocity fast, which is v1 plus v2 divided by 2, basically getting the average. Calculate the distance distance or height traveled using the equation distance equals rate times time, rate being the average velocity. Projectile motion is talked about then, and it says that range or horizontal distance traveled is a new value asked for in projectile motion. An equation used is range equals Vx times time. In the book, it said that whenever you see projectile motion, to always think that 1, the horizontal velocity doesn't change. 2, horizontal acceleration is 0. The vertical acceleration is always 10 meters per second downward, which means gravity. 4, that the vertical behavior is symmetrical. 5, time in the air depends on vertical component of velocity only. 6, that range depends on both the vertical and horizontal components of velocity. 7, time is always the same for both the x and y components of the motion. Then, how we mentioned that for the MCAT we have to know how to manipulate equations, and so the book gives us several equations, and we have to learn how to use them. It also talked about how for the second equation, the velocity equals the square root of 2 times gravity or acceleration times height or displacement, and it's probably the only equation that we will plug and chug. The other equations, it's more of a conceptual testing in the exam. For example, we might get asked the relationship between, if we accelerate, what would happen to the time? For example, the x equals half times acceleration times time squared. Just know like the relationship between all of the variables. And then it goes on talking about air resistance, which is the force exerted on projectiles or falling bodies due to actual physical collisions with air molecules. And then it mentions some factors that affect the magnitude of air resistance, which is cross-sectional area. So basically, if there's a greater cross-sectional area, there is more air resistance. If there is less aerodynamic, then there is more air resistance. And if there is an increase in velocity, there is more air resistance. But for most of the MCAT problems, we would have to assume that there is no air resistance, unless the passage or the question stem tells us otherwise. Finally, it talked about terminal velocity, and it basically states that when an object reaches terminal velocity, the object stopped accelerating, and then the forces of air resistance and gravity are now balanced.